All right, we're going to finish up writing equations of lines today. So if you remember, last class we talked about slope and slope-intercept form. Today we're going to talk about the other kinds of writing equations of lines, as well as parallel and perpendicular lines. So let's get started by talking about point slope. If you ask me, I think point slope is the most helpful one of all the equations of lines because you're going to have the most random points on your line, and point slope form is good for any random point that you have on your line. Remember, slope intercept form only works for that intercept, so point slope is best for any random point on your graph. The form is y minus y1 equals m parentheses x minus x1. M's your slope, and y1 and x1 are actually going to be numbers from the coordinate of your point that you're picking. How do you go through and write point slope form? Well, first you find the slope if you don't already have it. Go through and pick one of the points. If you have multiple points, if you only have one, then just pick that one. So pick a point and plug those in the right spots, the m for slope, and then your coordinates for your x1, y1 points. So you can see that first example down here. We had the point -3, -4, and a slope of 3/2. So I'm going to plug in the y part of the point over here with the y value, and the x part of the point over here with the x value, and then put in my slope. And then the only thing I need to do is simplify those negative numbers to a plus sign. So it becomes y plus 4 equals 3/2 x plus 3. Now, occasionally, when we're in point slope form, one of the things we need to do is change that to slope intercept form. So here are the steps you need to change point slope to slope intercept. We're going to distribute our slope, so get rid of those parentheses, and then we're going to add or subtract whatever number is on the y side so that y is all by itself. So if I take a look at my next practice or example problem, you'll see right here, first I had to go through and find my slope. So I took y2 minus y1, x2 minus x1, subtracted those, and got 5/7. Then I picked any one point. In this case, I picked the -5, -1. But if you wanted to pick 2, 4, you could totally do that. Plug that in for your y1, x1 values, and I got y plus 1 equals 5/7 x plus 5. So there's the equation in point slope form. Then I needed to change that to slope intercept form. So I'm going to go ahead and distribute that 5/7 to both the x and the 5. And that gave me 5/7 x and 25/7. And then I had this plus 1 on the y side that I needed to get rid of. So I'm going to subtract 1 on both sides. And if I do that, then I get 5/7 x plus 18/7. Remember, if you need help doing the subtraction, you can use that calculator with that fraction bar just to take 25/7 and subtract 1. So my total answer here in slope intercept form is y equals 5/7 x plus 18/7. So that's point slope form. Next up is standard form. And if you remember, standard form is an equation where you have ax plus by equals c. Notice those x and y's are on the same side. That's what makes it unique here, not y by itself. And we also want to remind you that in standard form, you're not going to have fractions or decimals. You're going to actually multiply to get rid of those numbers. And we're also going to change to standard form, but we're not actually going to ever start there. So that's going to be the last step in our problems, and you're probably going to have to put it in slope intercept or point slope form first. So how do we get to standard form? Well, first make sure it's in slope intercept form. So if you were in point slope form, change it to slope intercept and then go on from there. Get x and y on the same side. So remember I told you that x and y are on the same side. That's a little unusual here. So you're probably going to have to do some addition or subtraction and get x and y on the same side. And then we're going to multiply to get rid of all of those fractions and decimals. If it's a fraction, we're going to multiply by our greatest common denominator. If it's a decimal, we're going to try to multiply by a number that will get rid of those decimals. All right, let's take a look at that one. So again, I have 2 points, so I'm going to need to find the slope first, subtract in the y1 minus y2, x1 minus x2, and I get a slope of 5/2. Since neither of these points is the y-intercept, I had to put it in point slope form first. So y minus 2 equals 5/2, x minus -1 really is y minus 2 equals 5/2 x plus 1. So right here is my point slope form. That's great, but I can't do anything yet. I need to get it in slope intercept form first. So I'm going to distribute and then add my 2 to both sides, and that gives me y equals 5/2 x plus 9/2. There's my slope intercept form. So far, so good, but I got to keep going, and that's where I'm going to go and head and take this and get my x and y on the same side. So I'm going to subtract my 5/2 x on both sides, and that's going to get my 5/2 on the left side and get rid of it over here. And then I'm going to look and I'm going to see that there's a 2 in the denominator for each of these fractions. So I'm going to multiply everything in parentheses by 2 because that's the number in the denominator. If I multiply by 2, that will get rid of those 2's at the bottom. So I do 5 times 2 divided by 2 is 5. 2 times 1 is 2, and 2 times 9 divided by 2 is 9. So that gives me negative 5x plus 2y equals 9. Okay. All right. One other thing we can do with standard form is go through and find out intercepts. So if you remember, your intercepts are your points where your graph crosses the axis, either x or y. And when that happens, you are actually going to be on one of the axes, which means one of the values, x or y, is going to be equal to 0. So if you take a look, the x-intercept is where y is 0, and the y-intercept is where x is 0. It's the opposite. And how do we find those intercepts? We're going to go ahead and plug in 0 for that number in our equation and then solve for the other variable. So if I'm finding my x-intercept, I plug in 0 for y and solve for x. Over here, I'm going to plug in 0 for x and solve for y. Here's my example. My equation says 3x minus 4y equals 12. So on one hand, I'm going to plug in 0 for y and solve for x, and that gives me my x-intercept. Over here, I'm going to plug in 0 for x and solve for y, and that gives me my y-intercept. Those will be really helpful when we get to graphing at the end of this review group. Okay. So let's talk real quick about parallel and perpendicular lines. So there's a couple of things we learned about parallel and perpendicular lines. Parallel lines never intersect, and their slopes are the same. That's the key right there. The slopes are the same. Over here for perpendicular lines, they intersect, and they intersect at exactly a right angle. The key for perpendicular lines is that the slopes are opposite reciprocals. Remember, opposite means the opposite sign, so plus or minus, whatever you don't have. And reciprocal means the fraction or the flipped fraction of your value. So you'll notice right here my perpendicular slopes. If I have a 6, then the flipped version of that will be 1/6. This 6 is positive, so this is going to be negative 1/6. All right, when we write our equations for parallel and perpendicular lines, we first need to figure out what the slope was, and then use that to help us figure out what the new slope is going to be. Since it's parallel, or if it's parallel, then the slopes will be the same, so you won't have to do much work there. If it's perpendicular, you need to find that opposite reciprocal slope. Then you're going to put it in point slope form and change it to slope intercept if they ask you to, or all the way to standard if they really ask you to, but we're always going to start in point slope form. So if we take a look at our parallel line example here, I have the point -1, -1, and I want it to be parallel to this negative 6x plus 4. Remember, I'm only concerned with the negative 6. I really don't care about this plus 4 at all. So if the slope here is negative 6, then that means the slope of my parallel line has to be the same, which is also negative 6. So if I go through and plug in y minus -1 equals negative 6 parentheses x minus -1, then I simplify that, distribute, and subtract 1 to both sides, and I get y equals negative 6x minus 7. If I graphed both of those, negative 6x plus 4 and negative 6x minus 7, then I would find that I have a set of parallel lines. And that's how you can double check to see if you did that correctly. You can plug those in on your calculator and double check to make sure they're parallel. All right, last one. If you go through and do perpendicular, it's going to be a lot of the same steps, except when I go to find my slope, which here is 4/3, I need to use the opposite reciprocal in my new equation. So I'm going to take this 4/3, flip it upside down, and make it negative. That gives me the new slope I want to use is negative 3/4. Put it in point slope form, simplify if necessary, go through, distribute my slope, and then subtract 2 on both sides to get my final answer in slope intercept form. Now there's lots of optional practice down here. If you need to go through and do a couple of those before you work on your Math Excel, that's for a grade. These are all optional practice, and the answers here are at the bottom. If you have any questions, feel free to email me.